Welcome back, guys. Welcome to my YouTube channel. In this video, we'll try to solve LeetCode problem 61, which is about rotating a linked list by k elements to the right. So this will be one more video which will be added to our LeetCode series. So what they are essentially trying to do is you have a given linked list where you have to shift it right by k places and calculate the new head and the new tail. The problem states that you only are given with the current head, which is the definition of the linked list, right? You need an entry point to start to traverse to the through the through the complete linked list, right? So what they are essentially trying to say is that if you have a linked list 1 2 3 4 and 5, if you rotate it once, the old tail, right, the last element um, will become the first element, right? So it will become 5 1 2 3 and 4. So let's try to solve this problem step by step. First being, let's have a look. Let's say that we have the linked list 1 2 3 4 and 5, this one, right? And if we rotate it once, this 5 will become the first element. It will become 5 1 2 3 and 4, right? And then if we rotate it the second time, right, if we rotate it the second time, it will become 4 5 1 2 and 3. So what we have to do is, first we have to check what if we rotate it 5 times. The length of the linked list is 5 right now, right? What if we rotated the 5 times? So this will again become the same linked list, essentially the same linked list where the head is 1 and tail is 5, right? So what if we do it 10 times, right? So this will be rotating it twice, right? 5 times plus 5 times. So again the 1 will remain as head and 5 will remain as tail. So in this case, right, if our length is equal to the number of rotations, we'll simply return head, saying that hey, there was no rotation, and we'll return head in this case, right? Now for example, if we rotate it 12 times, right, so can we say it is 5 plus 5 plus 2, right? So that means the total rotations are effective k, the number of rotations will become 2. So that's it. So that's the first step we need to take care of. We need to find what are my effective rotations. In order to do that, first what we need to do is we need to calculate the length of this list, right? So what we can do is, how we calculate the length of the list is by traversing through all nodes. We'll have a variable and we'll keep on incrementing it. Once we get the length, we will also get the tail as well. If we traverse from 1 to 5, we'll get the old tail as well. Next will be to actually move our head to 4, right? So this item, so it will be this item. This will become our new head, right? And this will become our new tail. So if you observe this problem, let's say the total length was 5. We calculated the tail and the length was 5, right? If you look at this problem, right, so this should be our new tail, right? So how far is this tail from the initial head? So it's 1 and 2, right? So the steps that I need to take from current head, from our old head, which was our original head, to the new tail, is 2 is 2, which is essentially equal to length minus k, right? So we know that if we need to calculate the new tail, we need to move, k steps, right? We need to move length minus k steps from our head, from our old head, and then we'll get the new tail. Once we have the new tail, we can say tail dot next is my actual head, and then we'll break this line so that 4 becomes our new head. So, but in order to do that, what we will do first is we will connect this 5 to 1. We'll say, hey, start connecting, create a link between 5 and 1 so that, once we break this list here, the first node, my head will be 4, then 5, then 1, then 2 and 3, so which is equivalent to our rotated linked list. So what will be our steps to resolve this, or what will be our steps to calculate or to find an algorithm to do it? So the first step would be to write a base case. If k is 0, right, or if head is null, or if head dot next is null, we'll simply return head at that time, right? The second step will be to calculate the length, right? Length and tail, right? So once we are done with this one, we will calculate effective k, right? Effective k, k mod length, total length, right? So after this, once we calculate effective k, if k again becomes 0, we'll simply say again return head. And then the step number 5 would be to calculate find new tail, actually, right, which will be length minus k steps from old head, right? Once this is done, we can simply say our tail dot next is, or whichever new tail, right? New tail dot next is our, or we can say head equals new tail dot next, and then finally we'll break this link here. We'll break this link and say we'll say simply new tail dot next equals null, right? New tail dot next equals null. So, and then return our new head, right? So we can call this one as new head. Let's try to code it and see if we are able to actually write code for this one and submit it. Let's see. Let me go back to LeetCode. So as I said, the first step will be to check for the base case, right? The base case would be, hey, if my head is null, or if head dot next, if there's only one single element, points to null, right? Or if I have to do 0 rotations. At that time, what I will do is I will simply return my head return head, right? Okay, the second step was to calculate the length and the tail, find the length and the tail. So which we can do by traversing through the linked list. So we'll start from, let's say, length equals 1. Okay, and then we'll say list node, our tail equals head, so that we start from the first node. And then the basics, how to traverse through the linked list. We can say while tail dot next is not equal to null. If we have not reached to the last node, tail equals tail dot next, right? And we'll keep on incrementing length. Okay, so once this is done, once we have the length, the next step will be to calculate the effective k, to see if how many number of rotations we need to do. So if the number was 13, we'll say 5 plus 5 plus 3, so that will be 3 rotations only, which we will be able to find using the modular. How many times this number will fit into it, right? So yeah, so let's go back and say k will become k modular length. Okay, so after this we again check if my k became 0, right? Then we simply again return the head. So we will again write an if condition, where if k becomes 0, return head, right? So yeah, and once this is done, we'll connect the tail with the head, right? We'll connect this tail with the head. Okay, how do we do that? We'll say since we already know the tail, now we have the tail, we can simply say tail dot next equals head, right? It points to head now. Okay, so the next step will be to new, so if k became, find new tail, right? So yeah, so here we connected connect old tail to old head, right? Then what we need to do is we need to calculate the new tail, right? So the new tail will be how many steps far from the current head? 1, 2, right? Which is length minus k. So we can say int steps to new tail is actually equal to total length minus k, right? And then yeah, so once this is done, we need to find the new tail. So first let's create an new tail node. Let's say new tail equals, we'll start from the head again because we need to traverse. So once this is done, we can then loop through again starting from the head, which is our new tail variable, new tail reference, right? So for I int I equals 1, I is less than steps to new tail, right? And then I plus plus, and then we will say new tail equals new tail dot next. Okay, Now the next step would be to find the new head, which is equal to new tail dot next. So we can say list node new head equals new tail dot next, and then we'll break that the final one will be to break that link between 3 and 4, between between the new tail and the new head, so that 4 becomes the entry point and 3 becomes the tail. 4 5 1 2 and 3. So which is simple, we can say new tail dot next equals null. Okay, so cool. And finally we need to return our new head as well. Return new head, right? Yeah, public list node, right? We need to return our new head. Yep, looks good. Let's try to run this and see. Okay, so we have an issue here. What it says is if head equals null, head dot next equals null, or k equals null, we are returning head, right? Sorry, I'm missing one equal to sign here, right? So yeah. All right, yeah, so both cases 0 1 and 2, k is 4, it will become 2 0 1, expected output 2 0 1, yeah, correct. Or 1 2 3 4 5 when k was 2 4 5 1 2 3. Okay, cool. Let's try to submit it now. All right, cool. All right, thanks much. Thanks for watching this video. We'll add this to our LeetCode series. All right, bye bye.